class on engineering physics subject. So today we will be starting with the new module. Okay, module number 2. That is the thing, but the elasticity. Okay, so it's a module number 2. Okay, elasticity. Okay, now is the screen visible, students?
Yes, sir.
Okay, just a minute. So elasticity chapter or the module number 2, elasticity. So it is also a very lengthy chapter and very interesting as well. Okay. So here this chapter is actually very important in the sense for an engineering student. Okay. From the perspective of the materials, okay. So this is the chapter that we will be beginning, elasticity, that is the module number 2. Okay. So again, as we have discussed in the last part, this is also very lengthier chapter, and it has a lot of mathematical stuffs in it, mathematical concepts in detail and mathematical analysis, then mathematical derivations. After that, introduction elasticity, then you have the bending of beams. Then after that, there is a torsion of a pendulum or torsion oscillations. Okay, so these are the three subtopics or three topics of this chapter, and main part is elasticity. The remaining two are the derived chapters of elasticity. Okay, so let us begin the introduction of the elasticity. So you have learned elasticity in your earlier classes in high school and in PUC first year. Okay. So here, why we should study elasticity? What is the reason you should study elasticity in physics? Now, this is because for an engineering student, okay, for an engineer, for any engineer, if you have, so the one of the goal of an engineer is to choose appropriate material. Appropriate means suitable material for applications. Suitable material for applications. Now, if you you have one simple what you say case. You are purchasing a computer laptop. Now you want to purchase a laptop. How you check the laptop? You check the laptop by its specification. I want whether an Intel microprocessor or any other than Intel. Okay, you have many other like AMD and other thing like this. Then you will choose what is the RAM you require. Then you choose what is the ROM, that is hard disk you require. Okay, then what is the operating system you require. Then which software it can handle, those things you require. That you will make a list of specification and you will choose a laptop. You are getting the point. You will make a set. So for engineer in the first sem, for completing engineering, I want a laptop which is of so and so configuration. Okay, this is the minimum configuration. I will choose it. After 4 years of engineering, you go to a new field. There you require a different set of different laptop or different computer. Okay, so there you will have higher processing speed with graphics card, higher RAM, higher ROM. Okay, all things are required. But now you require a simple one. So you judge that you require a simple one based on your requirement. Okay, and the requirement of the laptop. So this is the right laptop I need. I will choose it. So you know the quality of that laptop. Therefore, you will usually choose for your purchasing. Likewise, when as an engineer, you have to choose a certain material for a certain applications. For example, you want to choose an wire. Okay, I want to have purchase a wire. Which wire you are going to purchase? Are you going to purchase a wire which is made up of copper, aluminium, or gold? Which one you are going to purchase? So you will purchase the one that I will mention here. That is the thing, but the copper. Okay, we will purchase the copper because it is having high conductivity than aluminium. You are getting the point. So you know that the copper material, the wire which is made up of copper, is having you will choose copper because copper has high electrical properties. What is the meaning of high electrical property? High electrical property means it is having conductivity. So high conductivity. So based on the conductivity, I will choose that copper among these three, aluminum, copper and gold. Copper is the best one. Therefore, I will purchase a wire which is made up of copper. So this is in case of an electrical applications. In case of an electrical applications, you are an engineer, you are choosing a wire. So you should know the properties of the wire, different wires which are made up of different materials. Copper wire, aluminum wire, gold wire. So we will choose copper because of high conductivity. You will not choose aluminum because conductivity is low, and we will not choose the gold because gold is costlier and you cannot have the gold wire and other thing. Therefore, economical as well as the electrical property both are high. Therefore, we usually we choose the copper for the electrical application of wire. Now there is one more application. For example, I have many industrial applications and other similar applications. I have many industrial applications and other. Okay, applications and other. For example, I want a steel material. I want a steel material. Okay, so I want a steel material and other applications. Okay, and other applications. Okay, for example, I have a vehicle. Okay, okay. I want to have a vehicle or four-wheeler. Okay, a car. Okay, a car. I want to manufacture a car. I want to prepare the body of a car. So when I want to choose a body of a car, what I will check? I will check the strength of the material that I am going to purchase. Okay, so I want to have a four-wheeler. So when I want to design a four-wheeler or I want to manufacture a four-wheeler, just an example I'm giving you, manufacture a four-wheeler, that is a car. Okay, any vehicle. Okay, a four-wheeler. Okay. Got it. So I want to build a body. Particularly, I'm interested in building the body of a car. So this is a car, old car I have, ambassador car. Okay. So this is a car. Now, if I want to have a car, so I first need a body. I need a body for the car. So which material you are using, then comes the point. Okay, I'm using a aluminum, I'm using a copper, I'm using a steel, I'm using a mild steel. Okay, so those are the questions that will come to your mind. So which one? Is it aluminum? Is it copper? Is it iron? Okay, or any other combination of these elements, compound element, aluminum, copper. Okay, then iron, steel. Okay, likewise, there are set of materials that are present in the market, and I want to prepare the body of the car. How you will choose which one is this? Are you going to choose aluminum, copper, iron, or in other iron in the form of steel? Which one you are going to choose becomes a question. Then you can choose the material for the building of a body of a car by knowing its elasticity property of a body. Elastic property of the materials. What you should know? You should know the elastic properties of aluminum. Okay, copper, iron, and steel. If you know the elastic properties of these, then I can choose the right material for the body of the car. You're getting the point? Similarly, there is one more application. Okay. So I have to construct a metallic bridge, hanging bridge like this. I will construct a hanging bridge like this. It's a bridge. Okay. So I want to construct a hanging bridge like this. So which material I want to use? Okay, what is the material? Am I using aluminium, copper, iron, or steel? Okay, or any other material? How I should know? I should know the right material. Which is the right material I should know? Is it aluminium, copper, iron, steel? Okay, it all depends upon the elastic property of the material. If you know the elastic property of the material, I can choose which is the right material for us to use it for constructing the bridge. Similarly, if I know the elastic properties of the material, I can easily know the body of a, I can easily use the material to make the body of a vehicle. Similarly, I am using a construction. I am building a house. Okay. I am building a house. Okay. I am building a house or any of the construction if I have. So this is the house I will need. Okay. What I do, I will use lot of steel in it. Okay, so steel and okay, so I'm using a steel. Why? Because it is having large number of beams. Okay, so in civil engineering studying, you had consist of large number of pillars and beams. When you are using a pillar, there are large number of steel that we are using. Steel wires are steel tubes, which we are metal tubes which are using. Okay, rods which are using that are composing in the uh, pillar as well as in the beams. So the beams means they are nothing but the horizontal structures like this. So it is consisting of large number of smaller rods. So which rods you want? Okay, I want aluminum, copper, steel, and other things. So you can know it. Okay, you can choose which are the things you require. Okay, based on the elastic properties of the material, based on the elastic properties. Okay, of the material. Okay, so elastic property basically gives you, in simple words, the elastic properties. If you know, okay, from these properties I can easily tell what is the force that it can handle. Force the material can handle. You're getting the point. How much is the force it can handle? That means I'm using a bridge, I'm using a material and to have the bridge. Okay, so what is the maximum force it can handle? You're getting the point. It is handling some force. How much is the force it can handle? If the force is too much, it is going to break up. Similarly, here I am using only one storage. If I have two storage like this, two storage house, the first ground storage, ground level, and this is the first level, first storage. Okay, so the first level. So depending upon these materials that we are using, we can decide we should go for ground plus one, ground plus two structures like this. Okay. Likewise, we can know the force the material can handle. Material can handle. Okay. So based on this, I can easily tell the right material. Also, knowing the elasticity properties, okay, of the material, we can design proper structures. We can design proper structures. Okay, so this is a structure. House is a structure. Car body is a structure. Okay, then bridge is a structure. These are all structure we can design properly if you know the things. Okay, so designing means here in the case of civil engineering, what is the beam? So the what is the beam? Then we here in the beam we are using a steel rod. So what should be the diameter of the rod? Okay, so if the diameter of the rod depending upon the diameter of the rod, it will handle more of the force. Suppose if you have decided to have a iron material for the construction of a pillar. So what is the diameter? So the diameter is not known. So that you can decide what is the diameter that we should have. Likewise, in any engineering applications, the material elastic properties, okay, can help to design the things in a proper way. Okay, similarly, if the material is in a earthquake zone, so if the construction in the civil engineering, okay, if it is in an earthquake sensitive zone, okay, so if the construction if the construction is in earthquake sensitive zone, okay, then I have to have properly know all the properties of elasticity so that I can design the house or car or the bridge in a right way. So this is the reason why you should know the electrical properties. Okay, then what is this elasticity? What is the elasticity? How you define elasticity? Okay, elasticity. So elasticity is actually a physical property of a material. It is a physical property, or it's also called as a mechanical property. Mechanical property of a material. Okay, physical or mechanical property. Mechanical property of a material. Is that one of the properties of the material? Okay, got it. Elasticity. Okay, so as I told you, from knowing the elasticity property, okay, I can design all these things as I told you. Okay, now how you define elasticity? Okay, so first I'll give an example. You have already learned this example of a spring. Okay, we have seen the spring. If I have the spring like this, it is now in a horizontal case. So this is the spring in rest position. We have not applied any force. Okay, this is the horizontal now. Now what I do, I apply a force in this direction. Once I apply a force in the direction, there is an elongation in the spring. There is an elongation in the spring. This was the actual direction of the actual position of the spring. Okay. Now after applying the force, it gets elongated. It gets elongated like this. Now it was at the position y equal to 0. Now after elongation, it has reached the position A. It has reached the position A. Now this is the direction of the force that you have. You have already learned it. Okay. So many times I've told you. Now it is in a horizontal, and this one is in the vertical state. It is the vertical vibrations like this. Okay. So I have the spring. What I do, I apply a force. Once I apply a force, there's an extension in the spring like this. So the direction of the force is like this. This is the direction of the force. So once I apply the force, this was the actual position y equal to 0. Once I apply a force in the body, okay, you will feel that by pulling it, you pull it. Once you pull the spring, okay, you will have an feeling that there is something, one force which is trying to oppose this pull. Whatever the pull you have created, that is being opposed by one internal force. One internal force like this. Okay. So leave the, if you remove the force, whatever you have applied, the spring goes back to its original state. Spring goes back to the original state. You have felt it like this. It's going to go back to its original state. Once you pull, there is a change in the length. If you remove the force, if I make the force equal to 0, it comes back to its original state. Why it is coming back? Because there is a force which is acting in the reverse direction, that is called as a restoring force. There is a restoring force that is present. Due to the restoring force, it comes back to its original position. So this is the original position that you have. Original position of the spring. Got it. What I have done, I have applied a force. How? By pulling it. Likewise here, this is the original position. Okay. What I have done, I have applied a force. Once I apply a force, there is a change in the position. After that, if I remove the force, what happens? It will go back to its original position. So this is the thing, but the spring which is exhibiting the elasticity property, which is exhibiting the elasticity property. Got it. There is other example also. So if you go to any sweet shop, okay, they will give a box, okay, like this. They will give a box, okay. On the box, you have one rubber which is wound like this. You are getting the point. It perfectly fits the. This is a rubber, okay. Okay, we just it's a not correct word. It's a, we call just as a rubber, so that we are using it. Now, if you take that rubber, this is the rubber, and if you stretch it, if you apply the force, this rubber gets elongated like this. So this is the force you apply. Once you apply the force, it gets elongated. Okay, so this is the direction of the force. So it gets elongated. So if you hold it here, if you fix it here, and if you pull it, so it gets elongated. Again, if you remove the force, what happens? It will come back to its original shape. This is the original shape of the rubber. Okay. This is at the applied force. Okay. It gets elongated. It is elongated. Elongated means extended. Okay. There is a increase in the length. So this is elongated. The rubber is elongated. If you leave the force is made zero, then it comes back to its original state. Original state. You're getting the point. So this is also the property that is exhibited by the rubber. This is also the elasticity property. Okay. Likewise, all the materials will exhibit one or the other level of elasticity. Now look here, I have given you two perfect examples. Spring. If you pull the spring and once you pull the spring, there is a deformation in the spring. Okay. Once you leave, it will go back to the original state. So, okay. So this is nothing but the deformed state. This is nothing but the deformed state. You are getting the point. This is nothing but the deformation that has been taken place. So this is known as the deformation. Deformation. There is a change in shape, direction, or the size. Okay, there's a deformation. Here also there is elongation. Elongation means deformation of the object. There is a deformation that is taking place. Okay, so once you apply the force, okay, there is a deformation taking place in the both the cases. Okay, in rubber as well as in the spring. If you remove the force, then it will go back to its original state. It is going back to its original state when you remove the force. When you remove the force, got it? When the force is removed, that is called as deforming force. If the force is removed, it is going to back to its original state. Similarly here, when you apply the force, okay, it gets deformed. Deformation is taking place. After removing the force, it goes back to the original state. So therefore, I can define as elasticity. I can define it as the property, okay, in which elasticity, okay, okay. So elasticity, okay, I can define it like this. Okay, so elasticity, okay, as I told you, is a physical property. Is a physical property or a mechanical property. How you define it? So if I define it, there are many ways of defining it. I will define in a simple way. So it is the property of a system, or it is a property in which a body, it's a property of a body, property of a property of a body such that the body or an object, or I said body, regains its original shape and size after removing the applied force, or applied, I'd say it as deformation force, applied or deformation force. So it is a property of a body such that the body regains its original shape after shape and size. Okay, original shape and size after removing the applied force or removing the deformation force. If you look at the spring, okay, or the rubber that you have, this was the original shape. You are getting the point. This was the original shape. So this is the spring what I have. So this is the original spring. Okay, this is the original spring. What I have done, I have applied the force. I have deformed. So there is a deformation in the system. So when you apply the force, once you apply the force, there is a deformation. Okay. After removing the force, if I make the force F equal to 0, it should go back to its original state, original shape and size. This property we call it as an elasticity. Similarly, here I have a rubber. Okay, the rubber has an original shape. This is the original shape of a rubber. Okay, I will. This is small in size and dimension. I will apply the force. I will elongate it. It is elongated. There is a deformation. Once you have the deformation due to the application of the force, after that I can remove the force. Once I remove, it goes back to the original state. This property we call it as the elasticity property of the material. Now, keep in mind, all materials exhibit, almost all material, okay, almost all material exhibit, not all, I'm asking you, almost all materials, all material exhibit the elasticity property. Okay, I have given you the example of a spring and rubber. Okay, you will ask me whether metals, okay, metals also exhibit the elasticity to some level. Okay, then plastic is also an elastic material, but it's a different material, but it is also exhibiting the elasticity. Don't worry about it. Okay, all metals, you can take copper, iron, whatever the metals you have, they also exhibit the elasticity. Then wood also exhibits some level of elasticity. You are getting the point. Irrespective of the material, all materials will exhibit the elasticity property. You are getting the point. Now, there is a term known as, you should call as a rigid body, a term known as a rigid body. Okay. Okay, we have learned what is rigid body. A rigid body is actually a fixed body. It is a fixed body in its position. Fixed body, which is a body which is fixed at a certain position. Fixed at a certain position. Okay, so if I take this as a rigid body, okay, if I take this as a rigid body, it is fixed at this end, and if any force is applied, on the body, which body? On the rigid body, okay, on the rigid body. This is actually a rigid body which is fixed, okay, and such a rigid body has the property that the force is not acting on it properly, not acting. The force will not act on it. Is the force F will not act on it, not act on it. What is the meaning of this? What is the meaning of this not act? Now here, once you apply a force for a rigid body, what happens is that the force will not have any effect on the body. Okay, act means here effect. It is not going to effect on the rigid body. What is the meaning of effect? That means as you apply the force, as you apply the force here, the force is such, whatever the level of force it may be, the force will not affect the body. It is not going to affect it. Affect means what? It is not going to change its behavior. Okay, there is no effect or no effect on the body. So what happens here? No effect means, okay, the force that is incident applied will create no changes are created. That means it is sticking to its own position. No changes are created. That means it is not changing. It is not changing. You're getting the point. So whatever the force you apply, due to the application of the force, there may be a compression like this. That means you applied the force. Okay, there may be a compression. This is the length L. Okay, so the length L may get decreased to L dash. There may be a change in volume. There may be a change in length. There may be a change in force, change in shape. But for a rigid body, these things will not happen. Okay, but in nature, no, you cannot have a perfect rigid body. Therefore, here there is no perfect rigid body. There is no perfect rigid body. No perfect rigid body. So all bodies, irrespective if it is a rigid body or not rigid body, it is going to exhibit the elasticity. So it's no perfect rigid body. Therefore, a rigid body, okay, will change in shape, size, change in shape or in size. There will be a change in size or shape or in size. Okay. So body will change in irrespective. Okay, irrespective. Okay. So there is no perfect rigid body. Therefore, rigid body will change in shape or in size when force is applied. When force is applied. You are getting the point? Actually, rigid body, when a force is applied to a rigid body, yeah, there should be no change in dimensions or change in shape, change in size. It should be as it is, but it is not so. There is no perfect rigid body. Therefore, rigid body will also have a change in their shape and size. Okay, so such material we call it as a rigid body. Okay, so hope you got the meaning of elasticity. Now go for the next few terms that you should know. So that is known as a perfect elastic material. Okay, or a perfect elastic material. Perfect elastic material. Perfect elastic material. What is this perfect elastic material? What do you mean by this perfect elastic material? Okay. Now in the definition I have learned that what is the definition of elasticity? It is a property of a body such that the body regains its original shape and size after removing the applied force or deformation force. That is known as elastic body. Elastic body. Any body which is going back to its original shape. Now, if what is a perfect elastic body? A perfect elastic body is a body is a body which regains its original shape original shape and size immediately or quickly, outside as quickly, as soon as the applied force or it's also called as deformation force is removed. So such a material we call it as a perfect elastic material. So here there is no 100% perfect elastic material. Okay. So there is no 100%. There is no perfect elastic material. There is no perfect elastic material. Keep in mind, in reality, there is no perfect elastic material. Only we can have a degree of perfect elasticity. So the one that is exhibited, one that exhibits perfect elasticity property is the chords. Okay. Okay. The chords is the one which is exhibiting the highest degree of, it is exhibiting highest degree of elasticity, degree of perfect elasticity. Okay, got it. So it is just an order. I cannot say the quartz is 100% perfect elastic material. No, in nature you cannot get a perfect elastic material. Only thing, it is a matter of comparison. Matter of comparison means whether the material that I am choosing is a better elastic material than the other. Okay. Likewise, I can also define a other term called as plasticity. Okay, I have defined what is elasticity first. Now I have to define what is plasticity. Plasticity means if a body does not regain the original shape and size. If a body does not regain its original shape and size after removing the applied force, deploying the applied bar deformation force, applied bar deformation force. Okay, and remains in deformed position, deformed shape, deformed shape or size, that material we called as is called as plasticity. That material is called as, that property is called as plasticity, and the material that exhibit plasticity is called as plastic materials. Okay, and the materials which exhibit plasticity, they are called as plastic materials. Okay, now what is this plasticity? I told you. Now here I have a spring. Okay, what I have done, I have applied the force. I have a spring here which is fixed at one end like this. This is the position. I have applied a force. Once I applied a force, okay, after application of the force, there is a deformation like this. So there is a extension in the length. This is called as the deformation. Hinge deformation item. Okay, this is the direction of the force. If I remove the force, then it goes back to the original shape. This is the original shape. Okay, this is the original shape. This is the deformed shape. Okay, now this is called as elastic or elasticity. But for plasticity, it is not like that. If I have a material, for example, a spring, let us assume it, you have a spring. Actually, it is not possible. Spring cannot be in plastic. So I have a material. So the material is having a certain shape like this. Okay. Okay. Like I have a certain shape like this. Okay. I will use our. Okay. I will use one plastic. I will use a one material like this. This is a material. Okay, I have one material which is in the form of a wire. It may be any material. Okay. Now what I have done, I have applied a force in the downward direction. So once I apply the force in the downward direction, okay, there is an deformation in the body. This is the actual length, original length. You are getting the point. It is the original length. After application of the force, what has happened? There is a deformation. There is an increase in the length of the wire like this. There is a increase in the length of the wire. Let us assume this is the increase in the length of the wire. The original length was L like this. This is the original length L. Okay. This is the original length. Okay. The force I have applied is like this. Now, what has happened after deformation? Okay, after deformation, okay, there's an increase in the length. This much is the increase. So this is the length, actual length. Okay, I have applied the force. The increase in the length is x. Okay. Now I have made the force equal to 0. If the force is made 0, it is not going back to its original state. It is not going back to the original shape. It is remaining in the deformed shape like this. So this is the deformed shape like this. Okay. So this is the new length of the wire. Okay. New length of the wire. Okay. So this is known as the plastic material. This is called as the plastic material. You are getting the point. What is plastic material? Material, when it is deformed, it stays in the deformed state even when I remove the applied force. I will remove the applied force. The force is 0, but still it is retained in the deformed state. Therefore, we call it that material as a plastic material. Now, the elastic material or elasticity, as I told you, it is a material, it's a property which regains its original shape and size. So, spring is a perfect example where it is where it is going to gain its original shape and size. You get the point. So, this is plastic, while this is actually plastic material, while this is the elastic material. Okay. Now, what is this elastic material? So, elastic material is a material, okay, materials which exhibit elasticity property, okay. They are called as elastic material. They are called as elastic materials. They are called as elastic materials. Okay, keep in mind, just for your information, there is no perfect elastic material, perfect elastic. Okay. And also at the same time, there is no plastic material, perfect plastic. Okay. So there is no perfect elastic. Keep in mind, there is no perfect elastic material. Okay, so I have given you the example of a quartz. Quartz material is the one which can exhibit elasticity perfectly with a high degree, but it's not 100% plastic. Now, likewise, I can define one more term that is called as plastic. I have defined all plastic already defined. Now I should define a property that is called as the, okay, I have defined plasticity now. Okay, I should also define perfect plastic. What is this perfect plastic? As we have defined perfect elastic, I should define perfect plastic material. What is this perfect plastic material? Perfect plasticity. Okay, so it is a property of a body that a body remains in the deformed state, deformed state permanently, permanently, permanently. Okay, after even after removing the applied force, removing the applied or deformation force, deformation force. Okay. As I told you, there is no perfect plastic material, but there is a material that we called as putty. So it is Putty. Okay, putty. Okay. So this is a material that we use in many of the applications. Okay, where we want to fix the things. For example, we are using the glass materials in a window. So in a window pane, I want to have a glass material. So what I will do is, this is the glass. Okay, I will fix it in a window. Once I fix it in a window, I should use some material, is it not? That material is a white material that we use, okay, to fix it, to fix the glass material to the window. That is a putty. So that putty is a perfect plastic material. That's nothing but a perfect plastic material. Okay. Okay. So this is the basics of the elasticity. Now here you should know one thing. Okay. The force that we are note. Okay. Keep in mind. Note means keep in mind. The force that we are applying to deform a body, that is called as deformation force. Okay. The force uh, that is applied, force applied. Okay. Force applied to a body to change to a body so as to change the shape or size of a body. Okay, so as to change the shape or size of a body, we call that force as the deformation force. We call that as a deformation force. You're getting the point. What is deformation? Deformation force, the force that is applied to a body so that there is a change in shape or size. Okay. Now here in this case, I have applied a force to the spring. Okay. In this case, I have applied a force here. This is the direction of the force that I have applied. This force is called as a deformation force. Okay. Here also the force that is applied to a spring. This is also a deformation force. This is also a force. This is also a deformation force. Okay. Basically, the applied force is called as the deformation. Deformation means because it is creating some deformation. Okay. So what is this deformation? Deformation means change. Okay. Deformation. What is this deformation? Deformation means it is a change in form. Okay. It is a thing but the change in form. Form means shape of a body. Change in form, therefore it's called as deformation. So change in form, shape, or I can also call it as size of a body, that is called as deformation. When you have the spring original length, you apply the force, there is a deformation. So this is the deformation. So this is known as the deformation. This much has been taken X. So the red is called as the deformation that has been taken place. Deformation. Okay. Similarly, I have a wire. Okay, the plastic material I have told you, just I'm giving an example. I have a wire. This is the wire. I have applied the force. Once I apply the force, there is a change in the length of the wire. This much is the length. So this is called as the deformation. This much has the change that has been taken place. This is the original length L. The change is known as the deformation. Okay. So it may be anything. For example, I have a structure like this. This is called as a parallelepiped. It is called as a parallelepiped structure. Okay, this is a parallelepiped structure. Now it is having a volume V. Okay, what I do, I apply the force in all the directions. So I apply the force here, force from this direction, from this direction, from this direction, from this direction, from all the direction. If I apply the force, there will be a change in the volume. That means it gets deformed. It is applied, the force is applied in all the direction. Therefore, it gets the shape changes. Not only the shape changes, the volume also gets changed. Why? Because the force is acting in all the direction. So the volume is decreased. So the new volume is V dash. So there is a change in volume. So how much is volume? Change in volume. Change in volume is change in volume. Okay, I can write change in volume. So change in volume is delta V. It is given by original volume minus the new volume. What is the new volume? New volume is V dash. Therefore, this change in volume, we call it as deformation. We call it as the deformation. Okay. Now, these are the basics now. There are, I told you what is the meaning of elasticity, rigid body, plasticity, then elasticity, elastic material, deformation, and other thing. Let us go for the basic terminologies that are associated with the elasticity. Basic terminologies that is associated. Basic terminologies that is associated with the elasticity. Force, you already know what is force. Okay, force is a physical entity. Okay, that is used to do some kind of work. Okay, force is some form of physical entity. Using force, we are doing some kind of work. That is nothing but force. You know the force you already done in your PUC classes. So there is a one term that you should know here. That's called as the stress. Okay. Varsha. Okay, so there is a stress, a term called as stress. You already learned what is stress. Okay, and there is one more term that is called as the strain. It's called as a strain. You have to study them in tandem. Okay, together you have to study. So what is this stress? What is this stress? Now I have a wire like this. Let us assume it. I have a wire. I have a wire. Okay, so this is the wire that I have. Okay, now once I have a wire, I can the wire is in the form of a circular rod, so it is in the form of a circular shape. I can take this as like this. Okay, so this is the wire what I have. So the wire is in the form of a circular shape. Now, for example, I have taken the wire can be any shape like this. So this is the wire. The wire can be in the shape of a, it is in the form of a cylinder. Now it can be also in the form of a rectangle. Okay, it can also be in the form of a rectangle like this. Okay, so this is the rectangular wire which is in the form of a rectangular shape. Any wire like this. Okay, okay, so this is the wire you can have. Now here once I apply the force, okay, this is the force, this is the actual length of the wire. Okay, uh, the length is L. Okay, this is the length of the wire. Okay, now what I have done, I have applied a force to it. So once I apply a force, okay, to the wire, okay, once I apply the force, it gets deformed. What happens? It gets deformed. Okay, so there is a change in the length of the wire. This much has the change that has taken place. So this is the deformation that is taken place, X. Now let us I take the area of the A be the area of the wire, cross sectional area of the wire. A be the cross section. Just I am giving you one example, cross section of the wire. Okay, then I can define. Okay, I just okay, I can define the stress as, okay, sorry, I just forgot to, okay, so this is the, okay, I'll define it in the coming class, don't worry. Now here once I apply a force, okay, uh, the force due to the application of the force, there is an elongation that is taking place, that has been taken place. There is some elongation. This is the elongation that has been taken place. This is the original length. Okay. Now, as you know, once you have applied the force, okay, after removing the force, it goes back to the original length, original shape. Okay, before I go to this part, I will just discuss some other thing. Okay, so there is some information. Once you apply the force, okay, the body, after removing the force, it goes back to the original shape. This is the original shape of the body. Okay, I'll erase it like this. Okay. So I should tell something. I just forgot to tell that before I go to these terminals, I should tell something else. Okay. Okay. So I have one material. Okay. I have applied the force. I have applied the force in this direction. Okay. So once I applied the force, okay, after removing the force, it should go back to the original shape. Original shape like this. It is going back to the original shape. So this is the original shape. Okay. It's very difficult now looking at the screen. No, I have to do it. Okay, so this is the original shape. So this is the original shape. Okay. Okay. Now I just forgot to tell you something about the restoring force that is present. Okay, restoring force. Just you should have it. Now once I apply the force, it is exhibiting elasticity. So let us assume it. This is exhibiting the elasticity property. Okay. Once you apply the force, after removing the force, it goes back to the original shape. Why it goes back to the original shape? Because there is some restoring force that is created in the system. Due to the restoring force, the body goes back to the original shape. So in the next class, why there is a restoring force in the system, that we check. Okay, and define the other terms. So I think the time's up. In the next class, we will deal this one in detail. So I shall stop here itself. Which is the next class you have? Hello?
Else.
Okay, fine. In the next class, you attend the EGDL. After this, tomorrow, if possible, I will engage it at 12:45. Okay. So if it is possible, otherwise on Monday we'll continue, or tomorrow I'll let you know. So we'll continue with this in the next class. I will let you know why there is a elasticity and why there is a restoring force. After that, I will define the remaining terms. Okay. So I shall stop here itself. Okay. Thank you for
Sir,
your time. Here.
screen
Hello.
share ಮಾಡಿ
ಮಾಡಿದೇನಲ್ಲ ಆಗಿಲ್ಲ.
ಅಲ್ಲಿ ಸರ್ ವಾಟ್ಸಪ್
ಇದು ಮಾಡ್ಬೇಕಾಯ್ತು ಸ್ಕ್ರೀನ್. ಓಕೆ ಮಾಡ್ತು. So I will share this one in the class. Don't worry. Okay. It is just an introduction class. I will share this and let you know. Okay. Fine. So you can leave the class and attend the next one. Okay. Thank you.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.